Hi, biochemistry students. Let's take a look at our slideshow section 4, which is the last part of Unit 6. What we've been doing so far is we've been learning how to balance equations, predict products, determine types of reactions, practicing that kind of thing. And now we'll finish up Unit 6 with kind of like what does that mean? And there's a concept called the mole. So we're going to investigate that. So let's take a look at our last section of the slideshow here. And so if we look at some of these ideas, the arrow, of course, means yields. And so like if you reacted a couple of reactants, then the arrow would mean that it results in or yields. And so there's some symbols there. Sometimes you might see things like an S after something, and that means that's a solid, or an L means it's a liquid. And so just keep that in mind that there are some symbols that pertain to chemical equations. Now, often when we talk about measuring things, we might say a dozen eggs, but in chemistry, it's the mole. So let's take a look at what is the mole. Now, really, the label you're going to use for this is simply MOL. The concept is known as the mole. Well, what it really is what they found out is that they took, if they had 12 grams of carbon, they counted out that that equates to exactly what's known as Avogadro's number, 6.022 times 10 to the 23. That's a huge amount of items. And so if you had Avogadro's number of carbon atoms, think about that. If you had that many small little atoms, 6.02 times 10 to the 23 of those atoms of carbon, you would have 12 grams. So that's kind of the measuring stick, I guess you could say, for when we talk about chemical reactions and so how they equal each other. And so that's how chemists can account for how much of something. Okay, so we'll be working with that quite a little bit. And here at in this last section of Unit 6, you'll learn about what we call mole ratios. Okay, so 1 mole of anything, it wouldn't matter if it's like these oxygen molecules or these hydrochloric acid compound molecules. If you had 1 mole of those, you would have Avogadro's number of those things. So let's take it a little bit further here. Later, we're going to equate that to mass by using atomic mass unit values, and we'll end up comparing things in terms of grams. But for right now, we'll just concentrate on the mole idea. Okay, so we'll kind of come back to this kind of thing later in a later unit. Okay, so again, the idea is what we're going to focus on here. This last part of Unit 6 is the mole ratios, and so let's see if we look up here at this balanced equation here, and that looks right as a balanced equation. Then our mole ratio becomes 2, 1, 2. So whatever you see as coefficients in front of the reactants and the products, that also equates to moles. And so once we learn how to do the mole ratio thing, then we can equate that to mass and grams eventually. Okay, keep going here. So for example, here is a balanced chemical equation for, it looks like cellular respiration, doesn't it? So you've got glucose and you've got oxygen, 6 oxygen molecules, and it produces carbon dioxide and water. And if we compare those values, then we see that's a balanced equation. But what this would be is a 1:6:6:6 mole ratio. Okay, I hope this helps, and just keep working hard, and you'll see how all this comes together. All right, thank you for watching.